Hello. Over the past 2 days, I've been working on uh, a tool website for 110. So 110tools.github.io. You can access that. And right now, the two features I have is a base converter and an emulator. So first, I'll just go over this very quickly. We can reset the layout and we can change the UI size. We can also change from dark to light theme, or just by default go with your system theme. And we can also move around all of our windows. So if we open up two different windows, we can move them on different sides of each other. We move them on top of each other. We tab them into each other. It's a little bit annoying sometimes. And we also close them. So first we're going to check out the base converter because that's the easiest. For some reason it's not starting with the default alphabet, but it will if I reset the layout. So I can enter something in base 10. So you can see down here, this is our from base and this is our to base. And so we're going to go from base 10 to base 2, which is from decimal to binary. So let's try 10. We know that this should be 1010 because that's 8 plus 2. There we are, it's 1010. We can also try putting it into base 16. Now that's going to be A because A represents 10. This works with any two different bases. Let's say that this is base 36 and we want to convert that to base 2. That didn't work. Oh no, wait, no, it probably did. Never mind. I just didn't read that properly. But I'm not going to go ahead and make sure it works. This should be 36 because 10 in a base is always the base itself. So this will be 36 in base 2. That looks right. That's probably 30. That's 32 plus 4. Yes, so there we are. I did actually make my app correctly. This is an emulator for the little assembly language we've been learning. So for example, we can have an input A and then we can add some B value. Let's just go in B and then load A and then I don't know, out store res and then out res. So this will add two numbers, and then we're going to say A and B are both just 0 by default, and res is also 0 by default. We can compile this. You can see it's turned everything into machine code, and it's still, for our utility, it's stored the lines that we programmed, mapped everything to addresses, and then displayed the lines we programmed, along with being able to display the machine code as well. Now you might notice that it does I definitely need to fix that. So that's not a true address, but I can fix that. The PC counter will be using the true address, and so will the green coloring. It's colored green if it's if the PC counter's on it. It's colored red if you've breakpointed it. There's also breakpointing. So if you want to run it and then it hits the breakpoint, it'll stop. If there's an error, for example, let's make an error here. Why doesn't that error? Probably. But if I make an actual error, like for example, that's not a proper label. Reset and compile. Label not found resi. That's orange because there's an error there. And here's our error. It's just run through because there was no halt, so it just ran through and it just kept on absorbing memory. And so I think I've put it in a weird state. There's a lot of bugs because I just did this over like the course of one day. So I do want to know, if you tell me any bug you find, I can solve it. But I need to go to I need to go to university soon, so I'm not going to do it now. So let's go back. Let's try running our program, right? Compile and run. It asks for our input for A. I don't know, 5, and you can enter this as well. 2, that should be 7, and it is 7. So here's a more complicated program I've prepared earlier. Let me just grab it because it was in my copy paste, but then I copied that other thing. So this is a factorial. All of this is multiplication. It just loops and then adds. I could probably have done it better. And this is the factorial bit. So let's reset and compile. Compiles correctly, and let's run it. And let's do the factorial of 5, which should be 120, I believe. This is going to take a little bit because it has multiple loops, but it's fun to watch. There are 120. I added some debug prints in it, but the final output's what matter. Because when I was programming this, I needed debugs. And here's a little speed guy. So if I set that to max, reset it, then run it, submit our input, and there we are, completed almost instantly. Very fast, very speedy. I think that's everything. I think, oh yeah, and these guys should be colored light blue, but they're not for some reason. I need to figure out why. I just did a whole bunch of work on this part here that makes them aligned, and I think I broke some of the code. This is a little bit scuffed because I was trying to make it as easy as possible for me to do. But if you want to check out the code, I have it all up on GitHub at my I have a GitHub page. I think it's just Jack crump-leys is my GitHub username, and it'll be the most recent thing I've committed to, or at least it'll be pretty recent. I think it's called like 110 tools or something. And you can have a look at the code. It's all in Rust, which is a cool programming language. But yeah, that's basically everything. I'm gonna add more things to this. I'm gonna add like a tool to understand how floats work. I might add a tool for like visualizing multiplexers, but I feel like that'd be pretty hard. That'd probably be the hardest thing. I don't know. Give me some suggestions, maybe.